3Dexperience SOLIDWORKS allows me to not only create compelling and seasonally correct designs like this sleigh, but also gives me access to powerful tools on the 3Dexperience platform that allow me to do things like analyze my design for resistance to wind. That's right, we're going to take a look at the Fluid Dynamics Engineer role found in the Sleigh brand of products here in 3Dexperience. Once I save my compelling seasonally correct design onto the platform, I can access it here through a web browser. You can see that I have some products already created, including an analysis in Fluid Dynamics Engineer. We'll go ahead and open that up. Interacting with my design is easy and straightforward, with some common navigational features such as a tree, ribbons, and keyboard shortcuts. In this particular analysis, we're using our sled, and we're going to pass some air over it at a particular speed. Everything we need to do is inside 3Dexperience Simulia in this particular role. I can take my geometry, clean things up if necessary, create a body-fitted mesh, which we'll take a look at in a few moments, and then through a guided process known as my assistant, we can easily add all the necessary steps to go ahead and analyze this design. Our materials come from a built-in library, as do our supports and all the boundary conditions, which you can see. But everything starts off with taking our geometry and meshing it. Here, this large brick-like structure is actually my hex-dominant mesh that surrounds the sled. You can see that in the inside. This is known as body fitting meshing, where we start off with one type of element and work our way into the geometry and start changing the mesh type so that it fits more accurately around our geometry, and that's going to improve the accuracy of our solution. Other aspects of this accurate physics solver is the types of boundary conditions. After applying those boundary conditions, we can request certain types of output that we can use for post-processing, making those colorful, cool-looking images and animations. The big box is surrounded by no-slip walls. Air is entering in one direction at 10 meters per second, and it's leaving the domain at 0 gauge. Basically, it's a wind tunnel. With the Fluid Dynamics Engineer role and the guided process, I can be assured that the geometry I use will be accurately and adequately handled for the types of physics I want to use, whether it's computational fluid dynamics, structural mechanics, be it static or dynamic, or electromagnetics. Using my task pane down here, I can navigate through the various commands, the setup of my physics, the boundary conditions, initial conditions such as initial temperature, pressure of the fluid, and interact with the finite element model we've created, make new materials, and then ultimately submit the job. Post-processing is also done from the action bar. Let's interact with the mesh a little bit. This mesh was automatically generated. There was no use of manual mesh controls or selecting faces and applying rules. The software simply saw the domain and saw the geometry and created the mesh. I ran this locally I have a 16 core machine. I can use those 16 cores, or I can use 16 cores on the cloud. And with tokens or credits, I can up that and get results even faster. When I solve locally, I can create an interaction that influences how I post-process or look at the results. Speaking of results, common computational fluid dynamics results include cut plots, section plots, isosurfaces, flow streams, looking at pressures, temperatures, velocities, and being able to interact, such as the probe tool, which allows me to pick off data points and store those for further post-processing. Line plots, other types of 3D plots, are all easily accessible inside Fluid Dynamics Engineer role. Modifying my cut sections and storing this content out for further digestion is easy and it's fun to do. One of my favorite visualization techniques are streamlines. This allows me to quickly ascertain where the flow is going, where it's not going, and that's going to help me make potential design decisions in the future. Hey, maybe we need a fairing on this. So let's create a brand new study, and I'll walk you through how easy this was. Each study is called an analysis case. And you can see I have a couple of different finite element models I can choose from. The one I've already built is just called Sleigh, and we'll use it for a steady state analysis. And I'm going to set a smaller number of iterations. It's a fairly small job and it should converge pretty quickly. Now heading down to my action bar, I can see I can have access to the various physics settings, which includes multiple different turbulence models. I can enable thermal effects if I want to do conjugate heat transfer. And I can easily hop between the various cases I've created. Now this second case has no procedures. There's nothing in it. So let's use our guided assistant to help us make sure that we get all the parts we need. All the model's in. Let's go ahead and activate some physics now. We'll use the standard SST solver. Our initial conditions, such as temperature or pressure, if we know how the solution is going to converge with what values, we might want to change our initial conditions to help speed that up. But for now, let's go ahead and add the velocity of the fluid on this face. And on the other side, we'll add an outlet pressure and then some no-slip walls around the sides. Notice that we support different wall conditions such as moving walls, rotating regions, symmetry. We can mimic the use of pumps or fan curves. And it's not just simple fluids such as this ideal gas of air. Non-Newtonian fluids such as chocolate or blood or applesauce. Yeah, it's a pretty weird list, but we can do it. Now I have no heat sources, but again, this could be a full heat transfer problem. Conduction, convection, radiation, we've got it covered. And then if there's any special output requests, any particular type of plots I wish to generate, or particular characteristic of the flow that I want to extract, those can be set up. The mesh has already been created, and now we just need to submit the job. Again, the 3Dexperience platform allows me some flexibility in this. I can solve it locally, post-process locally, mesh locally, or I can do that on the cloud. Again, 16 cores out of the box. That's not too bad, folks. Well, I hope you found that the setup is pretty straightforward. Analysis is really fun. Give 3Dexperience Works Simulia a try. Thanks for watching.